Hi everyone. So we are the SciDapp team, and I'd like to just introduce us first. We are scientists from ETH Zurich. So Gotthold is a PhD student, physicist, and I'm a molecular biologist. And we have also Dennis here. He's an open science advocate, and he has founded the Open Knowledge Island initiative. And actually, we bootstrapped this entire thing after we learned about this in about 10 days ago. We learned about it, so we are really fresh here. We have been all thinking though about the applications that blockchain technology can have in science already for some time, and we really try to implement something during this time here. So the idea that we have and the vision is that we create a platform that allows us to tackle the global problems that we are facing right now that are also related to sustainability through incentivizing a collaborative research. And for this, we want to build a platform, and we call it SciDapp. So to give you some examples how science, as we believe, is really the core of a sustainable development, I'd like to give you some examples. We are working in a biomedical research field at the moment, and so reproducibility is here one of the keywords. We basically could claim that we are in a science bubble or in a crisis, the so-called reproducibility crisis. And I mean, I've really experienced it myself, how difficult it is to assess clinical or scientific literature and find the reproducibility of these findings. So we, for instance, have here data that show that the reproducibility rates in psychology, but also in cancer biology, are between 10 and 40% only. So that's really a problem. And we would like to change that. Another example where science is really the driver of innovation and ultimately also in industrial innovation and for global growth is basically industry. So industry could not thrive without the ideas that scientists are producing and the shared knowledge that we can create. So this guy wouldn't actually have a business if he couldn't cite all the cool scientists that did a job before, right? So if you want to fly a rocket, you need to know that it actually also works. And finally, there's a problem, and that's the quality of education, or also open access problem. Right now, the data that we have generated in top-notch journals are hidden behind a paywall. So that is changing. There's initiatives in Germany that try now to sue or to make deals with these publishing companies to get data open. And we'd also believe it's not only open data, it has to be more than just that. But paywalls are a problem if you want to be inclusive and also look at communities that don't have such a background economically as, for instance, Europe and Switzerland especially. It's very difficult. There's also single points of failure in the current system. The internet is not optimal. As we have just experienced, NIH had to shut down PubMed. The data.gov servers were down for a few days due to the shutdown. So we need to remove these. And what's more, the currently generated data are apparently lost by a factor of 2 at least within 20 years. So what you generate of so-called knowledge today, in 20 years, half of that will be gone in the current system. So there's this amnesia problem. So how can we solve that? The problems that we identified for our app that we want to tackle is, first, we want to lower the entry barriers. So we want to allow anyone to access information globally, no matter which community he is living in. So no matter if there's a government that can afford paying open access to journals or paywalls or not. And we want to also change this antiquated infrastructure. There's one maybe very strong motivation behind it, and that's that we need to really learn how to collaborate, right? And currently the system is basically run by wrong incentives. We have the winner-takes-it-all mentality. That means you want to first have your cutting-edge patent, basically, and then you go out and market that stuff. That's really not the way that we should go. And we believe that blockchain can solve that. So with this, I want to hand over to Gotthold, who's going to explain you some of the technical aspects of what we have implemented here.
Right. So having identified these problems, we devised an infrastructure and a set of rules that would ultimately, or will ultimately, lead to this SciDapp, to this science decentralized application that will ensure universal access and creation of knowledge worldwide, and incentivizes fairness and collaboration through tokens. So I will walk you through now a little bit of the the coding that we did the last 2 days. Not really the coding, but the DApp that we have created. So on the left-hand side, you see the preliminary user interface. So the whole system rewards fairness and reproducibility via the reputation token. At the same time, it prevents spam via the scarcity of the power token. Those 2 tokens can be earned and rewarded in the system of the scientific, of scientific discoveries. Therefore, of course, you need to, submit, for instance, research proposals or data, and this data or these proposals, these written proposals, will be uploaded into a decentralized data storage, the interplanetary file system. This one will provide you with a hash. The hash will be then uploaded. Oh, I don't have a pointer. Well, whatever. Will be uploaded into the blockchain. So we are interfacing that thing currently to the Ethereum blockchain. So it is clear who did what. The end contribution, the data that you have acquired, it's locked in the system. You also provide a proposal name and some tags, and that costs you some power, so that you actually commit something. Now, let's say democracy starts. Now voting is started. Either the proposal gets accepted or, goes back for revision or something like that. People decide on that via a vote. Now, you yourself actually can participate in such a vote. Of course, not for the vote of your own stuff, but for the others. And this you do via staking reputation tokens. So you can fetch then via, the tags that were inserted into the system, what research data you want to see, and then you begin voting on the proposals, depending on your reputation, or for instance, whether you were able to reproduce those data or not. So this finally leads to something that we call the tree of knowledge via the recursive structure of our smart contract. Basically, one smart contract, so one proposal, one general project is creating different other projects, which again themselves create other different projects. So, and in the end, we get this kind of, knowledge tree. So for every different seeding problem. So at the beginning here, at the root, you would start with a problem. This is the problem you want to get solved, and then you let the thing develop. You see how science then is branching out. So and what you are left with then, ideally, is the persistent trail of evidence, an audit trail, kind of, where, at the end here, this is basically the insight that you want to have. You have also byproducts, even more insight, great, and that's the thing that you have in the end. So what is it that we think we will be, hopefully, in a few years? So we want to have created a social network for science in which everybody can participate according to his or her knowledge or desire to participate everywhere in the world, so that you have open data, everybody contributing, collaborating. You can even have things like AIs crawling or robots crawling that completely available net, begin apply deep data learning and get even more insights into the whole story, so that we actually can tackle problems like global problems in the world way more efficient via this kind of network. Okay, and that was it. Thank you a lot. We had a great time in the mountains.
So how was this according to what you expected?
Well, good question. I actually had no idea what to expect. So I didn't even know whether there would be anybody or 100 people. Everybody coders like crazy, and we needed to get into the coding because basically we started 7 days before. Actually we need to learn that language, right? Solidity somehow, yeah. And that was thanks to the help really of others and the mentors, that was possible. It was really great. I didn't expect that one. Really good.
Yeah, so I think we really, I'm very happy with the result now. So I've been thinking about the idea of how can we put data on the blockchain a long time, but what was really missing, I think, is this governance. Yeah, so how do you regulate it? And I think we are very happy to have implemented something now that is the first step. And generally, I just want to say that also it was a really cool time. Yeah, had a lot of fun. I couldn't get skiing though. That's the only problem.
We were just inside.
But it was a very nice experience. Yeah.
Apparently, Sebastian, who was one of our mentors, skied down the mountain one night
With his-
in his
with
suit.
my skis, right?
With
He
your
took my skis, yeah.
and in his suit to go to a meeting.
James Bond style.
How about you? What did you expect? How was this different than you expected, or what did you expect?
Sorry?
How was it? How did it measure up to what you expected?
We had very productive time, I have to say, and thanks to the help and the whole atmosphere which was created by organizers of the hackathon. I think we've done a lot, and we are looking forward to build on top of the work we've done. The goal is simple: to democratize and to enable access to knowledge by making scientific data verifiable, discoverable, and reproducible to anyone, anywhere, in order to enable shared future in fractured world.
That's amazing. Let's give these guys. Oh, we have questions.
So I understand, what data are you proposing to put on the blockchain? Is it the raw data that leads to the research,
Yes.
the derivative data,
So, no,
or
well,
the fact that a
you
research
can't-
paper exists?
So you can't. No. I mean, we can do it, but you don't put data on the blockchain. You put hashes on the blockchain.
Yeah.
The data have to be stored in IPFS, for instance. I wish that it's not just papers, because the whole thing, writing the papers and the story, I've doing that for 15 years now, and really I think what we need to put on is as soon as you have a idea and you write a cool experimental design, like a real experimental design, including statistical proposal of analysis and so on, you could write that on the blockchain. Others can see that.
The proposals,
Maybe even the proposal.
maybe?
And then the data, of course, right? The discoveries that are coming out.
We need to see.
Sorry, you said you're not putting data on the blockchain.
No.
Right.
No, on
data is
IPFS,
way too
right?
big
We are
to
hashing.
put it on a blockchain. You would pay millions.
Yeah.
You need to put it somewhere else onto the IPFS, get this hash, and this will be, proving if it's on the blockchain that this was the data that you have submitted, right?
So how does that make the data searchable?
Yeah. So the interfacing needs to be done. This we haven't faced right now. So we have a hash. This hash in IPFS gives the link at the same time. So via this hash you can find the data. So what is a really crucial thing that we need to tackle is really that we have the data indexed properly. So you will be an expert in, let's say, imaging or image analysis. So then, the text that we have provided that will be uploaded into the blockchain will basically make the things appearing, in your final app. Then you see somebody that you typically work with has uploaded something like that, and then you can engage and look, via this link, via this hash under the IPFS, look at the data and really also the raw data. We don't want to have spin stories or something.
No, but so I'm going to push you on this a little bit.
Sure.
Why do you need a blockchain for that if the underlying piece you're trying to get is more open APIs, for example?
Okay.
Because some of the data will be confidential. If you're doing cancer research or something like that, right? So what I'm trying to identify and really drill into and
Why
nail,
blockchain?
what does the blockchain piece specifically add to this?
To capture and to store metadata about data.
And not only
Data
that.
about data, basically. The data itself, the research will go anonymized to IPFS, and the solution needs to serve. First of all, it needs to fit into the scientist workflow, and it has to serve from the beginning, from hypothesis creation to the publication. So the publication of data. We know from for example, Director General of Science Foundation Ireland that 80% of scientists cannot produce research data 3 years after publishing the paper, and that's a real problem.
There's maybe one thing.
I'm not sure this solves the fact that scientists are
let me
rubbish at
start.
keeping data.
So
try it.
there's one problem here, and what blockchain can solve is remove third parties. Okay, so you do Bitcoin, remove the bank. So you
remove Elsevier.
Yeah, exactly.
Right.
So by doing that, you make sure that right now I know this, right? I do this all the time. I don't want to talk about my latest data because maybe this other group is doing the same. I even know they are doing it. They have the same genetic mouse model I want to work with, and I know I can't talk to them because they will just do the experiment.
You will get scooped,
We will get scooped, and that's awful because I know if we could have talked, we could have solved that. So there's cultural change required, but if you know that you can get a Nobel Prize because you've been part of such an audit trail, your discovery will always be locked, and for that has to be done immutable. So that's where the blockchain is important, and that's something that scientists did like way before. The guy Lavoisier who discovered oxygen, he put his discovery letter, the lab book sheet, in an envelope sending to the French Academy of Science, and 2 or 3 years later, he said, when others discovered it, but I did it 2 years before. So for scientists, it's very important that they know that their work is attributable, and that's we can solve.
So you could just start with authors and dates against papers.
Right.
Yeah.
I mean, ultimately, that would be the thing, that we do science for the sake of science. You know?
And Elsevier has a role, right? They can tap into this knowledge base, and they can discover what's really cool, and then they can write about it. Right?
Yeah, right.
But when they write about it, they do a really service, and it's not that we as the scientists have to write a story, do the figures. They make a screenshot of this, and we have to pay for that, and then the community has to pay. So we want to change that in a way.
Okay, so we do need to move along. If you have other questions, then maybe we can talk to them in the back of the room. Is there anything that's just pressing that you need to know? Yeah, we'll pass the mic there.
Thanks. How are you going to implement the social value protocol here? You know, what is it to check the authenticity, the integrity, the trust, and that type of criteria?
So that should be done through the logic of our tokens and the smart contracts, basically, that are doing this, right? And I mean, to start with, right? I mean, we are trying to tackle a really big problem here. You could imagine to test this also with a small community of scientists, that a funder provides money, that he says, I'm going to give you this money under certain conditions, and that they're somehow bound to the tokens, right? The way that we want to implement is that it's open. So you can open an account, and then within this account, you basically are able to submit in a month 2 times. But you then earn reputation over time when your data become reproduced. And with this, as you're going on, you will earn, because reputation is minting you this power again, you can make more commits, all right? So that's the social playing here. That requires a 2-token system where one token is non-transferable, the other one is transferable. And you have a staking of the reputation token in the way that in the audit trail, if you were doing something wrong, like voting, what happens in science very often, anonymous peer review, you're blocking it. So that...
I think she already understood what she
Okay,
wanted to know.
yeah,
all right.
Okay, so
I didn't want to interrupt.
So you can stake token. Maybe we can talk.
Yeah.
guys, thank you so much. Just give everyone a round of applause.
I know.
Thank you.
You can talk for hours like this.